So I could have chosen any picture from the internet, but if I just show you this picture very quickly, you can probably all tell me where it is. You'd be able to describe all sorts of factors about it based on your knowledge, your ability of to process the image in your brain, and the capacity of the eye to take all the information in. And if you spend a little time looking at it, you can pick out details as well. So that's really just to highlight the importance of data visualization, because if we can do for the tsunami of electronic data that comes at us what the eye and brain allows us to do with images like this, then we can make considerable progress. Fundamentals of vision. Well, sight is of course a key element of human evolution and survival. The visual field is complex, as we know. It processes huge amounts of data which change continuously, and it exists to interpret the world around us. So I'm really restating what I said on the other slide. But at present, interfaces to complex data are not really optimized for intuitive visual processing, and they don't effectively often tell the story in the data as well as they could do. I'm also interested in the passage of time, and these beautiful old brass clocks convey the message of the linearity of time as the metal balls roll down the slope of the clock, and of course the mechanics of the clock move with time. We all know, of course, that time is central to the description of the lives of almost all entities, from the solar system to the galaxy to the universe, right down to the smallest molecular entity. And we can describe most things by a series of information streams which pass through time, describing their physical form, their characteristics, their behavior, and so on and so forth. We could be describing, with the talk I'm giving today, a public institution, a commercial organization, the description of a life of an engineered entity, such as a building, a car, a ship, or an aeroplane. But in my particular field and with my interest, a human life, or in your field, even the life of a single white blood cell. The important point is that what we think we've done is stumbled on a universal way of looking at information. And although this particular talk is about the clinical applications of it, I really believe that this has opened up an opportunity for many other applications, which we can perhaps talk about at the end of the presentation. The other components of this is, of course, computers. The principles of data visualization have been around for centuries, but computers have transformed our ability to manipulate data, do all sorts of things with it. They give us huge speed of transmission, with the internet in particular. They give us huge speed of processing data and manipulation to do with almost what we want with data now. They have huge capacity for storage and rapid recall of data, and we can construct dynamic imagery and interfaces from the information that we're given, and this is all pretty standard stuff now. We can also interact with the computers, obviously, through iconography or all sorts of different tools for computer interfacing, and that's very important in this story as well. So the principles of what I'm going to talk about are really captured in this image. If we take our entity, which in this case is a human life or medical history of a human life, we can describe it on a series of parallel stacked timelines, and we can place on that timeline, using the metadata in the documents, the reports, the events that contribute to that human life. We can put them on the timeline as icons, which we can then hover over to give us the metadata describing when the icon was generated, by whom, on what date, and perhaps where, and what subject matter it contains. And then by clicking on the icon, we can open up and access the underlying document. So this is a very powerful way of looking at large numbers of documents in a very simple and elegant format. We can also start to read the patterns in the documents. The fact that we're only displaying the timelines which contain information is important. The relationships, the separation vertically and horizontally, all help us to understand what's going on with the subject matter. So the x-axis, the timeline, can also be of any length that we want, depending the entity that we're studying. In the human life, of course, it's going to be days, weeks, months, years. In the study of the universe, it would obviously be millennia and beyond that. So that's very flexible, as is the subject taxonomy. The taxonomy I'm going to talk about today is simply a taxonomy that we inherited from the era of paper in Southampton and the organization of data, which goes back well before computerization. If we look at the individual medical record, the ability to communicate information about a patient, you yourself, when you go to your doctor's surgery or to hospital, is obviously very important. You want all the information there, you want it in a timely fashion, you want it in an easy to read format. Paper really dominated the medical landscape right until the late 1990s. Computerization of healthcare goes back to the early 1960s, but most of it was related to administrative functions rather than medical and healthcare functions. And even now, paper is a major element of the medical record, and more problematically, simply capturing paper documents as PDFs and then putting them into a huge file makes the reading of the medical record very, very difficult indeed. From the 1990s onwards, there were a series of components of the medical record which evolved. Word processing obviously is important, document storage, order comms. These are the tools with which you request tests and get results back. And then, of course, the patient administration systems, which recruit patients, pass them through the system, make sure they go to the right doctors, and see them out at the other end of the process with summaries and relevant information. But the problem has been, certainly through the 2000s when I was starting to think about this, that the poor integration, poor interface design still dominates commercial software systems. They're largely built by developers for developers and purchasers, and the poor end user, which is you or me, trying to make sense of the information on the screen at the coal face, whether it's in the clinic or the laboratory or wherever, is often overlooked. So the irony or the paradox of computerization has been that in many ways it penalizes productivity, efficiency, clinical safety, and most important of all, user sanity, whether you're a general practitioner or a doctor or any other healthcare professional. And so getting the design of interfaces right is really very important, and it hasn't yet been achieved. Beyond that, a unitary, integrated, intuitive, responsive, whole of life and real-time electronic medical record, which had your healthcare records from your GP, from your hospital visits, which may be numerous different hospitals, from your dental surgery, from your time in prison, from your time in military service, and wherever else medical records are generated, has not really yet been achieved. And we certainly don't claim to have done that either, but what we have done, we think, is built a model where it is now possible to work towards a unitary medical record. So if we go back to the mid-2000s, the National Institute of Health commissioned a big report on where we are and where we want to be from the MITRE Corporation in the United States. And they came up with this diagram of where the world was in about 2006. There were a number of independent systems which covered administration, which covered nursing care, which covered laboratory testing, which had some clinical elements, radiology elements, pharmacy elements. But to get to them, you had to go through a node, pull the information separately from each of those systems, and then reconstruct the information about the patient in front of you at the time that you were seeing them. We could draw a parallel that you go into WH Smith's because you want to buy a magazine, and they say, certainly, sir, we'll sell you the magazine. Go and collect each of the pages off the various shelves which they're on, collate them together and bring them back to the desk, and we'll sell you the item. Oh, and by the way, some of them are mislabeled, so you may have to look around. We can see how inefficient that is, but that was really in effect what was happening in the 2000s. Where the report wanted to be was to be a system where you've still got all those information generating data tools, but they're processed by a black box which sits in the middle of the the pipeline between you and the original source records, and then collates it in such a way that all the information is integrated and available for you on a single screen, on a single view, and that would be ideal. But that approach hasn't really been achieved to any great success until we put our minds to it in about 2008, 2009 in Southampton. Now, this lovely little diagram, there'll be a test at the end of the talk on it, is the systems integration map for Southampton General Hospital. The purple streak is the integration engine that holds all the patient hospital numbers, and it pulls all the information from all these different systems together into the unitary clinical data estate for each and every record. Now, I only show you this just to show you how complex the task of creating an integrated medical record is. This is one hospital, and I'm sure that every hospital, every organization that you work with, if it put its mind to it, could produce a similarly complex data integration map as this. So this is not an easy problem, and we are far from complete with the work that we've done. But it gives an idea of the scale of the challenge, and if you multiply that map across the entirety of the NHS, the entirety of general practice, and every other organisation contributing healthcare information, you can see the scale of the challenge, because of course each organisation has its own taxonomies. What is classified as one subject area in one hospital will come up in a different area in a different data system. So it's a great challenge, and all I can do is show you what we've achieved in Southampton to date. So in 2010, we had done some work, which I'll talk about in a moment, on this concept of UHS Lifelines, which is the center of this talk. Lifelines is a name which was given to the system by Professor Ben Snyderman from his own work in the 1990s in the University of Maryland in Washington, DC. He was a guru of electronic data visualization, and this is really named in homage to him and his team, and he's aware of the work we've done. I've been over to talk to him, so this is really in recognition of their original thinking. I don't claim originality for the idea, but what we've been able to do is to convert the basic concept, which was an academic exercise in Maryland, into a real working system in Southampton. What we foresaw was that a computer interface in the Southampton University Hospitals Trust, as it then was, hospital integrated computer system, would be able to create a visually and graphically rich and informative environment, an interactive and adaptable patient record, from which different clinicians could obtain information on all of the diseases that they were treating in a range of different clinical environments, and which was scalable and timeline structured, so it would incrementally increase hour by hour, day by day as time passed. My original interest, having been editing a European cancer journal, was to be able to look at the timelines of individual cancer patients and break down the survival into the episodes of care from primary, secondary disease, and so on and so forth. And I'll show you later on how we achieved that. So this is all about understanding clinical outcomes rather than just simple administration, getting patient from A to Z through the pathway. And I must give great credit to Mr. Alan Hales, who is a computer systems specialist who had built many of the component systems of the University Hospital Southampton clinical data estate over the past decade. And when I approached him with the idea, he said, well, this is the first time I've been approached by a clinician as opposed to an administrator to build systems, so let's give it a go. And he put a huge amount of effort into it and has continued to do so. So this is not my programming work. I sit in the background asking for everything and getting what's achievable. So we've had a very good working relationship between, if you like, the concept creator and UX experience tester, which is all wrapped into one person, me, and all the rest of the systems development and coding, which has been done by Alan for much of the time that we've been working together. This is one of the original Lifelines concept diagrams, which came from the University of Maryland in 1997. by Ben Schneiderman and his team. And although it was not workable in the format they described it, what it shows, if you look at the left on the y-axis, they've created a series of subject taxonomy headings, and then they've spread out documents from the record and bar lines and all sorts of other bits of information in various formats and clutters along the x-axis. What they've also done is put in some searchable tools, and they've linked the imagery through to actual imagery. But this is a mock-up. This is not real-world testing. But I took this project to the IT team in Southampton as a blue skies exercise just to see what we could do. And within a year, Alan had come up with this format for me. This is a live screenshot in 2010 taken of a patient with complex comorbidities. And we'll come back to that later on because there's some other points to make about this. But it just shows that we've been around doing this for about 15 years now. And since the original concept discussions in 2009, and it has evolved considerably since the slide. So just to sort of in a very brief format, the development of the system which I'm talking about started in 2009, although my reading goes back a long time before that. The discussions within the trust were in 2009. At about the same time that the government digital service was being formed and starting to talk about agile and iterative in-house development of systems which are focused on the end user rather than the purchaser. We've worked entirely agile and iteratively, and the message is that you fail early, you fail fast, you try things, you do them, you put them on screen, you look at them. If they don't work, you go back a step and move forwards. And that way you can achieve great things with very little relative effort and cost, compared with waterfall systems for which the NHS has had a notoriously expensive experience going right back to the 1980s with the Wessex computerization at the Royal Hampshire County Hospital, going through the MP Fit program in the 2000s. This has been done all in-house with minimal resources apart from a bit of brain power and a few glasses of wine. We had freedom of operation within the UHS test environment. We had the IT teams on board, and they were very helpful on occasions in unlocking issues for us. But this has been really done as a small team exercise. And it then evolved through my surgical practice effectively for the user experience testing and the feeding back and the discussions right through to about 2016. In the course of this, we also developed and built a whole of life course breast cancer data system, which was my hinge for the project, and that now holds more than 20,000 whole of disease course records. We went live in the trust very cautiously in 2016 with a version of the older coded system, and we were able to iron out a lot of problems as things went forward. As you would expect, a complex system like this, each time you change one bit of code, some other problem comes to light. So all credit to Alan for a fantastic piece of work. We then recognized that with Microsoft changing its coding base and going over to Microsoft Edge and all sorts of other things happening in the wider world, we ought to rewrite the project. So with a graduate of University of Southampton Computer Sciences School, Matt Warren, we then rewrote the integrated system, which was locked into the code base of the hospital clinical data environment, and re-released it as an application which stands independently, but nevertheless works entirely within the UHS clinical data estate. We then went on to use the lessons that we'd learned about data visualization, both in the breast cancer data system and in the Lifelines tool, to build a module over and above the Somerset Cancer Registry, which is a system which has been taken on board by about 100 hospitals in the country for recording all of their cancer work. We built a module which made it much more clinically focused and now allows all of the cancer data in the hospital to be accessed by any health professional or clinician who wants to look at it. So that was a major gain as well. And it all stems from this original Lifelines tool and continual agile development. This is what the current screen looks like. Again, this is a live, a real screenshot that was taken in January 2023. And what I've done with this is highlight the key, or some of the key features which we built into the newer system. The first thing we've got is a look forward. So if you look to the right-hand side of the screen, because everything is moving from left to right, I've now highlighted an icon because our admin staff had said that it's all very well looking at the present, but we also need to know what clinics have been booked for patients, what x-rays, mammograms, and so on in future have been booked. So we built a look forward in exercise into the screen with data drawn from our patient administration system. The large vertical ovals relate to a collapse and expand function. The upper group is all documents from different subject areas: ophthalmology, medicine, elderly care, emergency department, so on and so forth. The central group is results and reports, and you can see included in that, just to make it very topical and relevant, there is a timeline for blood transfusion and blood group and saving. This was put in because our anaesthetists were particularly keen to be able to see what had been done at a glance when they were pre-assessing patients for surgery. And then the bottom group is the imagery timelines, CT scans, ultrasound scans, and so on and so forth. We had to put the collapse and expand functionality in because we recognized that in time there's a lot of other material that we would want to put underneath this, both from the hospital but also general practice, community care, and so on and so forth. So if this is going to evolve into a unitary global interface for every citizen's healthcare, you have to be able to create space while not losing the overall important mantra that you can visualize the entirety of the data set on the introductory screen. So it is important that you can navigate around a complex data environment like this, knowing where you are all the time. And so this format is very much of value in allowing you to do that. We've also put the admissions timeline. This is data drawn from the patient administration system, hospital admissions, because a lot of the data is generated around hospital admissions. So by putting it in the middle of the graphic, you can look up and down vertically to relate information, just as you can relate information horizontally over time along the x-axis. We've also got a calendar function in the bottom left-hand corner, and information about the iconography highlighted as well. Now, one of the problems that we faced was that every icon on the screen takes up a finite space, and we opted for a 12 by 12 pixel sized icon. But because every screen has a finite number of pixels on the screen, that's the fundamental of the computer screen design. If you have more than one icon intersecting on one subject line and one time point, then you have a problem, because the icons have to be either overlapped, in which case you can't see what's going on behind, or they have to be laid alongside each other, in which case the architecture of the interface is lost, because you've no longer got two-dimensional relationships of position between the subject matter and the time point. So we spend a lot of time thinking about this, and we eventually did some work with students at the School of Information Technology down at Southampton Solent, who were interested in doing some projects. And we came up with this solution, which is a hybrid solution. So where you see the cruciate icon, or what I call the hot cross bun icon, if you click on that, that displays all of the similar time point documents underlying it in a hybrid frame. So within the hybrid frame from this test case, you can see both a list on the left-hand side of those documents which relate to that time point, and then the document itself can be displayed by clicking on any of those documents. So it's a hybrid solution, but it works very well for us. So that's the basics of Lifelines, and as you can imagine, a lot of work has gone into developing that. Just a very quick look at the Southampton breast cancer data system, because this is very much a separate talk in itself. This is an early screenshot. We built for every patient who'd had breast neoplasia, whether pre-cancer or cancer, in our record system, which went right back to the 1970s. We created a single data data viewing point or data set for that patient, in which we integrated the Lifelines interface with the information population screens. And this allowed us to build the cancer events or the master timeline or the cancer life track, whatever we wish to call it, where for each principal episode, we could create, using an iconographic representation, a time point, which was then populated with pathology, treatment, and so on and so forth. Time passes, we come along to another time point, a new episode. In fact, this patient has a new cancer. And then at some point later, she, and I know she's she because there's an obstetric midwifery timeline there with lots of activity in it. She developed, in fact, I think it was a chronic leukemia and went on to die of that. I know this is a right-handed, right-sided cancer because we live in a port city where if you have navigation lights, green is starboard is right, and this is a left-sided cancer because red, of course, is port is left. We also built in a different iconography to indicate non-cancer tumors, so you can read the whole story of the patient on a single timeline. And just to show how we developed that further, this is just a management screen which tries again to preserve the principles of using dynamic imagery and dynamic histograms. So we separated out the patients who'd been primarily treated and diagnosed in Southampton from those patients who had been referred into Southampton from our partner hospitals in the region for chemotherapy, radiotherapy. This is a dynamic graphic, so clicking on it will bring up the underlying lists of patients. If you're red, you're dead, because of course this data set goes right back many decades. So we've got a lot of information on the entire life course of disease of patients who die, who have already died. And if you're green, you're still alive, self-evidently. And if you're orange, you're in another region where we're still trying to chase up information and outcomes because patients may have moved out of the area or whatever. So that dynamic principle applies to all of the component elements of the management screen, and that's quite an old screenshot now. This was another interesting and powerful tool which we haven't really exploited as I would like to yet. From this data set, you could specify any cohort of patients by a whole series of different factors, whether it's pathology or treatment or and by just setting those in and pressing replay, you pull up very rapidly a data set on those patients. But also we were able to display all of the timelines for all of the patients in that cohort. So you could then read the timeline, you could very quickly identify data entry errors. For example, a patient who was diagnosed with metastases 25 years ago certainly needs looking at because the chances are that was a data error entry. So this powerful visualization goes all the way through to the analytics as well. And it's my frustration that we haven't yet been able to exploit that tool as much as I would have liked. The other thing that we've done is built this Somerset Cancer Registry enhancement module, as I hinted at. And that means that now, using the same principles of dynamic histograms and dynamic information, imagery, color, and so on and so forth, we're able to pull up all of the cancer records in the trust since 1914. Since 2014, sorry, and to look at them, and I can pull out the list of patients who died in any one year, the orange and the living patients, and then we can take that information through to the multidisciplinary team meetings. So this tool is now available to all MDT attendees in all subject areas. This was taken from a breast cancer meeting back in 2020, and I've blacked out the patient details. But what we have now is the list for every patient who's attended the meeting, but linked to it is a view of the Lifelines interface and a view of the Southampton Breast Cancer Data System interface. So I could both update the information as the MDT proceeded, but also very rapidly each patient could be intelligently discussed with the entirety of the relevant information in front of them, rather than having to say, well, we don't know what the history was from 5 years or 10 years ago, because it's going to take too long in a meeting of 60 or 100 patients to dig it all out. So that's transformed the utility of our multidisciplinary team process as well. So in summary, we've built within one hospital system, and this is our problem as much as our solution, an integrated system which gives us a fully adapted EPR interface, and it was built at minimal cost without commissioning by the trust. We took the idea and it was accepted, and it was sufficiently powerful that it spoke for itself when it was complete. It's been optimized for the end user rather than the purchasing intermediaries, as with most systems in most hospitals. And we recognize that it's got considerable scope for further expansion within the hospital, across the region, across the whole NHS, and in fact, globally as well. I've been out to the United States. I've talked to people in Cleveland Clinic about the system, and they say, well, we'd love to have something like this because so much of our clinicians' expensive time is wasted just reassembling those magazines from the racks at WH Smith to get the patient record together in any one patient consultation. But most importantly, and I think of relevance to this presentation, is that we also recognize that this was a first-in-class exemplar of a way of organizing information with almost universal applications. You could organize your personal financial situation on this. You could put the history of Reading University on it, all sorts of different things. It's just a matter of building the momentum with it. So what I want to talk about briefly now, because I know that many of you are particularly interested in machine learning and AI, and I'm presently the subject chair for SCOPUS advisory board, the global system, which I look at all the medical journals. Of course, everybody's writing about AI with all its problems at the moment. Now, if I take you back to the original screen that I showed you, which I will in a moment, I'll show you how with clinical experience and common sense, that thing that trains your eye, brain, cortex function to be effective in your daily life, it's possible to read the story in the Lifelines interface, in the timelines displayed, the fact that timelines exist or do not exist, and the patterns in the iconography and the metadata without having access to any text underlying it. We could even further improve this by putting in timelines with rich information, for example, on what drugs you're treating a patient with. Because if you're treating somebody with insulin, it pretty much states that they've got diabetes, and if you're treating somebody with tamoxifen or an Arimidex, then they're and it's a lady that she's got breast cancer. It radically simplifies, in my understanding, the application of machine intelligence to the interpretation of the clinical story. Because if you go to AI, IT meetings about healthcare, everybody's talking about the challenges of reading the documentation, understanding what all those little arrows and squiggles mean in people's handwritten notes. But with this approach, it's possible that you will be able to get to a very high degree of fidelity in understanding the patient record without the need to pass the text, the handwriting, the diagrams within the clinical correspondence and notation, because the exercise becomes one of just measuring differences and distances and so on between the icons. And so you don't need to trust on that AI neural network black magic, which gives you a different answer every time you ask it the same question. And if it does give you the same answer, you don't quite know how it's achieved it. So the visualization of the individual record, in my view, probably feeds into the visualization of the analytics as well, because you can play back the analytics through the visual screen. This is the screen I showed you originally. Now, just to sort of show you the reading exercise, if I tell you that this patient, the screen covers the period from about 2003 to 2011, and the vertical dotted red line at the right side relates to the patient's death. We can now start to tell the story in this patient without knowing their name, their precise age, although the demographics of the patient was 16 at the start and 23. It's a she because we can see that there is a timeline of obstetrics and gynecology, which halves the population that we have to analyze. And then by looking at the patterns, we can see, for example, in the clinical pattern that there's a lot of medical activity going on over a number of years. But if we go to the real clue in the cancer care timeline and the medical oncology timeline, right around the time of death, there's a cluster of documents in each timeline relating to those subject areas. Now, that's very unusual in a 23-year-old, so something clearly very tragic and very nasty happened here. If we go to the histology timeline, we can see that this patient was getting biopsies over a very long period of time and very frequently. So it suggests that there was a condition, perhaps a bladder lesion, which was transforming over time, and so on and so forth. So by putting fairly expert interpretation onto the record and using mathematics and statistics, which are far beyond me, I believe that you could read this story to a fairly high degree of fidelity without ever having to pass the text. Now, we can go one step further than that, because we can also select out cohorts of patients. So University Hospital Southampton has got something between 2.5 million and 3 million individual patient record sets alive and dead since the patient administration system was created. Way more than 500 million reports. I suspect it's in the billions now by the time we add up all of the blood tests that are done every day, all the x-rays that are done, all the letters that are generated in clinics and so on and so forth. So from that, it should be possible to select out any cohort of patients, each of whom has also got a Lifelines interface, if you choose to call it up, to start making reasonable predictions about future healthcare requirements from where you are at present. So, for example, you could take all the patients from, let's say, 2000 and see how many of them went on to develop dementia or needed cardiac valves or diabetes or whatever, and then start trying to make sensible predictions about future resource needs. Why has it been possible in Southampton to do this and to be able to throw these ideas out? Well, the data quality in Southampton is fairly unique, because right back in the mid-1990s, decisions were made by our predecessors to standardize data, to standardize the subject taxonomy, so and to start digitizing information in standard formats at that time. So we've got something like a 10-year lead on hospitals that didn't start doing that till the mid-2000s. And that's been a huge benefit to us in building the system. In fact, our earliest electronic information goes back to 1990, when we revitalized a huge number of pathology records. About 350,000 pathology records were brought back to life from old Ferranti systems and those huge dinner plate sized disks on which the information was stored. So we've shown also that you can use old information by recapturing it if it's important enough to you to spend the resource to do so. So noting your particular group interest in AI, that I'll leave this talk there, one of my favorite paintings, just to throw open the discussion, because we've got some time, whether this triggers any thoughts about applications of the concept in your own specific fields, or more generally in life, that we can talk about and start thinking about developing. Thank you very much.